Okay. So, welcome back from break. So remember, we will not be meeting, um, well, obviously today or Wednesday. So the next time we will meet is in person on Friday. Um, I guess keep an eye on your email just in case we're going to meet online on Friday for any sort of reason. Um, but the plan is to meet in person on campus on Friday. So there'll be this lecture, and then I'll put up a second lecture so we'll end here at let's see, it's 11:15 my time, so I'll call it 12:05, I guess, something like that. And then I'll create a second lecture for the Wednesday lecture. Okay, so I'm going to start off by going over the midterm exam, and then we'll pick back up where we left off. So let me go over here. Let me open up Keynote. All right, and let's look at midterm. So let's look at the questions for the midterm. All right, I'm just gonna do it like this so I can see the questions easily. Okay, so in Unity, what's the difference between a normal collision and a trigger? So normal collisions automatically implement the physics of a collision without the programmer having an opportunity. Well, you know what? You can do on collision, so you could do interject some code in there if you wanted to. But normal collisions put the physics into the collision um, without the programmer having to do anything extra. Triggers do not run the collision through the physics engine and instead rely on the programmer to handle the logic of what happens when a collision occurs. So you could even add something like that, like this up here. The programmer could also interject some programming logic related to a normal collision if they want. Okay, but the kicker is whether or not the physics engine is called or not. All right, next one. Write a function named count chars that takes a string and a char as a parameter and returns the number of times that char appears in the string. So let me just put this out there. We'll left justify it. All right, so we are writing a function, um, not just a collection of code. So functions would be called count chars. It's going to take a string and a char as a parameter, and it's going to return a number. So it's going to return int. You know what? Let me just do it out here in online GDB, then I'll paste it in. All right. So we'll call this guy, you didn't have to put static in front of it if you didn't want to. Change this to Java. This isn't what I wanted you to do. I didn't want you to test it or anything. I'm just using it for formatting here. So I'm going to say static int because it's going to return an int. Call this guy count chars. And this guy's going to take a string as a parameter, and then the char we're looking for inside that string. And what it's asking us to do is return the number of times the char parameter appears in the string. So we want to create a count, start it off at 0. Then we want to loop through each character in the string. I is 0, I is less than s dot length, I plus plus. Each time through, we're going to ask a question. If s dot char at I, if the current character we're looking at is equivalent to the character we're looking for, then we'll increment our count. After we've gone through the entire string, we'll return count. All right, so something like that for our count chars. All right, we take a string as a parameter as well as a char, return an int representing the number of times this char appears inside of this string. Create a variable so we can remember the number of times we found it. Create a loop that goes through every character in our string. Each time through the string, look at the current character. So in Java, that's using the char at method. Compare it to the character we're looking for. If it's true, if we found it, increment count. After we've gone through the entire string, return our final count. I guess I'll just leave it in there like that. It's not that important. Okay, next question. What do threads allow us to accomplish in computer programming? Give an example what a thread would be helpful. Right. Okay, so threads allow us to create code that does not block, which effectively lets us have more than one thing act like it is happening at once. You could even say it might even be happening at the same time in a multi-core processor. Right? Maybe an example would be handling, I mean, you can come up with a bunch of different examples, but maybe something like with a multi-user server. So in a multi-user server where lots of people are trying to connect at one time, and each user has to authenticate with a username and password. Creating a thread for each user to authenticate them when they first connect allows other users to connect while the previous user is going through the authentication process. All right. So if 10 users want to log into the server at roughly the same time and they all try to connect to the server at the same time, as each of those people are connecting, the server would create a thread to go off to the side and help them authenticate so that the next user can actually try to connect to the server while they're busy doing it in the event that, well, I mean, even typing a username and password once takes a little bit of time, but if they keep screwing up or they have to go through the process of resetting a password or something like that, you don't want the next person to have to wait for 10 minutes before they can even connect to the server. All right. Next one. Create a Java class named Book that keeps track of a book's name and author, and the number of pages, create the appropriate fields with proper security settings and appropriate constructor, and getter methods for the fields in your class. Okay. Question in here, but we're going to go and write this. So, oh, I didn't actually copy the question, it appears. All right, so we're going to create a class called book, and it's going to keep track of the name, the author, and the number of pages. Start with that. All right, I'll just write it down here. So we're going to have class book. Put some spaces in here so we get this guy up to the top. All right, we're going to have a private string name, private string author, private int number of pages. Then we're going to have a constructor for this guy that will take in the string name, string author, int number of pages. And this guy will set the name equal to the name that was passed in, the author equal to the author that was passed in, and the number of pages equal to the number of pages that was passed in. All right, so these are our fields. We've set them as private, so we only have access to them inside this class. Here's our constructor. We set those fields. And then we're supposed to write the appropriate getters to give us read-only access to these values. So we'll say public get name, return this dot name, and this guy's going to return a string. Public string get author. This guy will return this dot author. And then public int get number of pages. Return this dot get number of pages. I'm sorry, this dot number of pages. All right, so remember that these guys, these function names don't have to be called this. These guys are just acting, they're behaving as a getter function or an accessor function that gives us access to private members of a class. So you can name this guy whatever you want, but ultimately the get name function here is going to return a string because what it's giving us is public access to this private field. Okay, but only read-only access. This function does not allow us to modify it. Okay, so there's our class book. Right, create a Java class book, track the book name, author, number of pages. We got the fields, proper security setting, and the constructor and getter methods. All right, so that is that one. All right, next one. Write a function named array2string that takes an array of integers as a parameter and returns a string with the contents of that array in it, with each element separated by a comma. For example, if the input was 1, 2, 3, 4, 5, stretch this down some. I can't grip it. The output should be 1, 2, 3, 4, 5. If you happen to throw an extra comma at the end, I did not take points off, but I'll go ahead and write it where it omits that. All right, so it's going to be called array2string. All right, and this guy is going, and you didn't have to put static in front of it. I since I'm not even compiling or running them here, I'm not sure why I'm doing it, but I am. Remember, static just makes it a class method. So if I were to call it from up here in main, since and actually, hold on. Why is it still showing the C version of Hello World up there when I changed the Java? Doesn't matter. It's not impacting what we're doing here. All right, so this guy is going to be, I forgot what it's called, array to string. So, and it's going to return a string, array to string. This guy's going to take an int array as a parameter. All right, and we're going to be building a new string. So we use the empty string to build up a string. I want to go through every element of my array. So for int I is equal to 0. I is less than ar.length. I also didn't take off for this, but in Java, the length of an array is a field. So it's not a function. So it's array.length, ar.length like that without the parentheses. Whereas a string does have the parentheses, but again, I did not want you running your code. So little errors like that were not big deals. All right. I plus plus. All right, so we're going through our string. Now we want to build up another string. So I'm just gonna do it first with that extra comma, and then I'll show you how to fix it. All right. So we're just gonna go ahead and say S is equal to S concatenated with AR at bucket I concatenated with a comma. All right, and I don't remember, did I say put spaces, no spaces in it? Okay, so S is going to equal whatever it's currently equal to plus, so concatenated with the current value in the array that we're looking at, followed by a comma. All right, and then in the end, we will return S. All right, now this would have been sufficient. I didn't take points off for this. But technically you are missing a little bit of logic, because what this would do is it would have an extra comma at the very end. All right. So the way to get around this is to do something like if I is equal to 0, S is equal to S concatenated with AR at bucket I, else I'll just S is equal to S concatenated with, I'll put the comma in first, followed by AR at bucket I. So now if it's the very first time through the loop, we're just going to be adding our one number to the array, or to the string rather. And then, but for each other time through the loop, we'll be tacking on a comma followed by the number, comma followed by a number, comma followed by a number. So the very last time through, we'll put on a comma followed by our very last number, leaving us with something that looks like this. So originally we just have a 1, then it's comma 2, comma 3, comma 4, comma 5. And then return our string that we built. Okay, so something along those lines. My intent was, and the one thing I really want you to get out of this, and because I obviously this is ad nausea at this point, but right from the very beginning of CSC200, I talk about all programming languages are the same, and 100% of languages have facilities for remembering things, asking questions, repetition. And if we just go through this stuff right now is what we've written so far, where remembering something, repetition, asking question, updating what we're remembering stuff. This is just giving us access to something we're remembering. Array to string, remember, repetition, ask questions. Right, so You know, that when you break down, a lot of times I'll like saying this idea that all hard problems are made up of a bunch of easy parts, something along those lines. All right. Next. In Unity, what is time delta and when would we use it? Okay. Time dot delta is or time dot delta time is the amount of time. Really, it's in seconds, but this would usually be some fraction of a fraction of a fraction of a second that has elapsed since the last time this, since the last time time dot delta time was called. We would use this when we want to create scenarios where something happens a little bit over time, ultimately giving the optics that it is smoothly, let's say something like animating. You know, kind of the idea being like if you have something on the screen and you move it a tiny bit every single frame, ultimately it's going to look like it's moving smoothly since we're showing, you know, 100 frames a second, 60 frames a second, whatever it is. So if you remember in class, we kind of talked about almost like the flip book for animations. And you have a whole bunch of pictures that are just slight little, you know, changes from the previous one, and you flip through it, you see it as an animation. So that's an example of when we might use delta time. Generically, it's whenever you need to know, you need to use the value for the amount of time that's elapsed since the last time you called this, when you want to do something relative to the last time you did it. All right, next one. Write a function named display nums that displays to the screen the numbers between 1 and 1,000. You may not use a loop, and you must do this recursively to earn credit. All right. Now, I didn't necessarily care if you included 1 or included 1,000. Didn't really matter. I really was focusing on the recursive part of this. Remember, recursion is when a function calls itself from within itself. So this guy is going to be called display nums, and notice it displays something to the screen. All right. So what I'm going to do here, so it's not going to return a value, it's displaying something. So this is going to be static void. It's not returning a value, it's displaying something. We'll call this guy display nums. All right. And what we're going to say is, you know, when we originally would call this, we would pass it a 1 perhaps. And then we would say if n is equivalent to 1,000, what are we going to do? We're going to say system.out.println n. Now, the reality is we're going to do that every single time. We're always going to print the number that was passed in. So when we passed on a 1, we'll print out a 1. We pass on a 5, we'll print out a 5. We pass on 1,000, we'll pass on 1,000. As long as n is less than or equal to 1,000. Actually, if it's equal to 1,000, we've already printed it. So as long as it's less than 1,000, what do we want to do? We want to call display nums passing it n plus 1. This is us calling it recursively. So if we pass display nums a number 1 initially, we'll display to the screen a 1. Is 1 less than 1,000? Yes, it is. So call display numbers nums on 2. Call display nums on 3, on 4, on 5, on 6, all the way up to display nums on 1,000. Print out 1,000. Is 1,000 less than 1,000? No, it's not. So we're done. That's when the recursion finally ends. All right. So notice we do not have a loop in there. Instead, we're creating the behavior of a loop through recursive calls. All right. All right. In Unity, what's the difference between start and update? Give an example of when you would use each. Start and update are both built-in functions for mono behaviors. Start is called exactly one time when a script first starts. And if you wanted to elaborate for each game object, this script is attached to. So if the script is attached to 10 different game objects, that start function will get called 10 different times, once for each of those game objects. Update is called once per frame for each game object the script is attached to. All right, so update is called once per frame for each game object the script is attached to. So start is used to do any initialization for this script or game object that happens when the script first begins. Update is used to perform logic every single opportunity that another frame is displayed to the user. Could be used for listening, for button clicks, or animating objects, etc. All right, something along those lines. Next one. In Unity, what is a mono behavior and why do we remove it from some of the classes we have written? So, mono behaviors are Unity specific classes that are purpose built for attaching to game objects. They come with a collection of built-in functions that allow us to respond to events associated with this script, as well as things like collisions. Sometimes we want to have normal C# classes that are not meant to be attached to a game object. Perhaps for keeping track of behind the scenes data that we use in a traditional way rather in a Unity specific way. Since these are never attached to game objects, we may remove the mono behavior-ness. That is to say, don't inherit from mono behavior, so that the class can stand on its own without being called upon by the game engine automatically. All right, something along those lines. And last, what are design patterns and what is the MVC design pattern? So a design pattern is a proposed good solution to a common problem. That could mean lots of different things. How good is a good solution and how common is a common problem? It's going to depend on, you know, the person and the thing that you're solving. I think in class I probably use an example of what's the best way to make a peanut butter and jelly or something like that. And you know, you can talk to 10 different people and maybe there's 2 or 3 different approaches to making peanut butter and jellies that each of those people kind of feels is the right way to do it. All right. Note that this is not an implementation, but rather a suggestion as to the best way to go about implementing it. So if somebody tells you the best way to make a peanut butter and jelly sandwich, they're not actually making it for you. They're just giving you kind of the recipe for how you would go about making it in an optimized way. And then you would choose to actually implement it the way that you wanted to implement it in the spirit of that design pattern and that suggestion. MVC stands for Model View Controller, which says that it is a good idea to keep your data separate from your user interface, separate from your, let's call it logic code. Go with that. Model is the data, view is the user interface, and controller is the logic code. Okay, so something along those lines was the solution to the exam. In general, people did fairly well in the exam. There were some low grades. I would definitely take a look at you know, your exam. You know, there's feedback where you screwed up at least in some cases. I tend to give less feedback on exams unless it's really necessary. just because of the time it takes to grade them. So maybe you don't get a whole lot of feedback for correct answers, but I do try to give you a little bit of stuff when you have an incorrect answer. But in any case, if you did poorly in the exam, ask yourself, what was the reason for this? Is it you weren't putting enough time into the homework? Were you relying on other people for doing too much of the work for you if you were working in groups, and you weren't actually learning as much as you needed to? Did you not practice as much between homework assignments, kind of working on your own little things? Um, uh, or in some cases is programming just not for you. Remember back from the very first course, I kind of talk about computer programming being like a sport. You can academically learn how to do something. If you are a baseball player, somebody can teach you how to hit a fastball. But until you've actually swung at, 10,000 fastballs and practice it and gotten better at timing and hand-eye coordination and all that stuff, you're not actually going to get much better at actually hitting it, even if you understood a long time ago the mechanism for how to hit a fastball, something like that. All right. So, be honest with yourself as to the reason why you haven't gotten better at the programming stuff. And in most cases, I do reach out to students who I feel just this isn't their cup of tea to get you into the major that's the best fit for you early on, rather than you spinning your wheels in the wrong major, only to be, $100,000 in debt and then not being very good at your job. So I want you where God wants you. And if that's in computer science, that's great. If that's in some other field, let me help you find that. Um, but more times than not, it's that you're treating your computer programming class like a traditional academic class that maybe is more about memorization, or something you can cram for, where you can just study a lot the night before the exam and accumulate a whole bunch of information that you can spit out on an exam. Not that that's not still valuable in some cases, but programming is not that type of thing. You really need to put in the reps, and unfortunately, that comes at the cost of time. And most of you have already seen that sometimes you have to spend more time than maybe you would have liked on some of your homework assignments. But I promise you that it will be worth it in the end. And hopefully, you're already seeing that things that took you a long time before would not take you very much time now, but they've been replaced with brand new things that take you a long time to do. All right. Sorry if you hear the ringing. My room phone is ringing. I'll just wait for it to shut up. So, all right. So while that's finishing up, let me transition over to our Unity project and see where we left off. And we'll work on that here for a few minutes. And then I'll stop this video and get it uploaded. And then I'll start the second part of the lecture for the Wednesday class. All right. Man, they're persistent. It's just ringing off the hook over there. This is our project. All right. It finally stopped. Hopefully for good. That's a Vision Pro project I was working on. Was that what was preventing it? Why won't you open? Kill Unity. I'll kill Unity Hub as well, since he seems to be having some struggles. But why? It seems to be fine on my end. Let's open up a Unity directly. See if I can get that guy to behave a little better. Okay, something's starting to happen now. Perhaps. What I really want to accomplish here at the end of this lecture is just to review where we left off. Not sure why things are taking so long. Just close some other applications here and a couple of these things might be taking up quite a bit of system resources, although I do have 50 gigs free. Well, let me just do this since we only have 7 minutes left in this particular class. I'll stop this lecture now. I'll get this finished loading correctly or restart my computer or whatever I need to do to get it loaded, and I'll just get caught up at the beginning of the next lecture, which will be our Wednesday lecture. So obviously no homework for Wednesday because I really haven't gotten into anything. There may be homework for Friday. I have to see where we get to on the Wednesday lecture. But again, a reminder that we will be back on in-class meeting on Friday this week. All right, I will see everybody in the next video for Wednesday.